Hello, this is Holly Sanders, and welcome to the Clarified series. In this section, we will be focusing on basic renal anatomy. Unit 1, General Urinary Anatomy. Let's start by taking a look at the kidneys. The kidneys are located retroperitoneal, which means behind the peritoneum. And on top of each kidney are the adrenal glands, which are part of the endocrine system. Coming out of each kidney are the ureters, which take urine to the bladder, where it is held until it is finally released to the outside of the body through the urethra. Let's do a quick overview of the major blood vessels associated with the kidney. We'll start with the abdominal aorta, which will deliver blood to the kidneys through the renal arteries. When blood exits the kidneys, it goes through the renal veins, which will meet up with the inferior vena cava to take blood back to the heart. Welcome to Unit 2, Anatomy of the Kidney. When looking at a sagittal view of the kidney, three different regions are visible. The outer region is called the renal cortex. The middle region is the renal medulla. And lastly, the inner region is the renal pelvis. The renal medulla has many triangular regions called the renal pyramids. The area where the ureters and blood vessels enter and exit the kidney is called the hilum. Unit 2 review. Unit 3, the nephron. Start our study of the nephron with the glomerulus, which is the filtering unit of the kidney. There are over 1 million nephrons in each kidney, which means each kidney has over 1 million filtering units. Within the glomerulus, it's broken into an area called Bowman's space, Bowman's capsule, and the glomerular capillaries. Let's look at the basic function of the glomerulus. First, blood enters the afferent arteriole, and then it goes into the glomerular capillaries. The capillaries separate blood into plasma and formed elements. The plasma, which is now called filtrate, enters Bowman's space and then goes into Bowman's capsule. The formed elements exit the glomerulus through the efferent arteriole. Now let's follow the filtrate through the nephron. After exiting Bowman's capsule, filtrate enters the proximal convoluted tube. This is located in the renal cortex. Next, it goes through the loop of Henle, which is located in the renal medulla. And then finally, it will work its way back up to the renal cortex to the portion called the distal convoluted tube. The distal convoluted tube dumps filtrate into the collecting duct, which runs through the renal cortex, medulla, and finally drops filtrate off into the renal pelvis, where it can now be referred to as urine. Lastly, note that there are peritubular capillaries running the entire length of the nephron. In order for blood to be filtered by the glomerular capillaries, it's going to have to get smaller along its journey. Starting with the renal artery, it will branch into the segmental arteries, then into the interlobular arteries, the arcuate arteries, and finally into the cortical radiate arteries, which are found in the renal cortex, where blood will enter the glomerulus. Now that blood has entered the glomerulus, it will go through the afferent arteriole, into the glomerular capillaries and out through the efferent arteriole, through the peritubular capillaries, to the cortical radiate vein and the arcuate vein. Next, we'll look at how blood will exit the kidney to meet up with the vena cava to go back into circulation. The arcuate veins, interlobular veins, which finally meet up with the renal vein where blood exits the kidney through the hilum. From the renal vein, blood will enter the inferior vena cava, which will deliver it back to the heart. Blood enters the glomerulus through the afferent arteriole, where it then hits the glomerular capillaries. This is where blood is separated into plasma and formed elements. We now refer to the plasma as filtrate, and it enters Bowman's space and then into Bowman's capsule. Next, we'll look at how filtrate moves through the nephron. It starts in Bowman's space and then moves into Bowman's capsule. Next, into the proximal convoluted tube, through the loop of Henle, into the distal convoluted tube, and it finally exits the nephron through the collecting duct. From the collecting duct, filtrate will move into the renal pelvis. This is when we can refer to it as urine. Urine will then move into the ureter. Urine will move down the ureter into the bladder, which holds it until it's ready to be released through the urethra to the outside of the body. Unit 6, the 3 major renal processes. Let's start by doing a quick blood review. If you were to centrifuge a vial of blood, you would notice that it separates into 2 major components. The first component is on top, and it is called the plasma, and it's mostly formed of water, some hormones, nutrients, and other things that move through our blood. And then the bottom section is what we refer to as the formed elements. The formed elements consist of the red blood cells and the white blood cells, which are significantly larger than the plasma. Now it's time to bring it all together by taking a short look at renal physiology. Step 1, glomerular filtration. In this process, the glomerulus acts like a net to separate blood into plasma and formed elements. The thin, watery plasma goes into Bowman's capsule and then through the nephron and is now called filtrate, whereas the much larger red and white blood cells that make up the formed elements go into the efferent arteriole and are going to travel into the peritubular capillaries. Step 2, tubular reabsorption. In this process, blood is going to reclaim many needed elements before it re-enters circulation. Tubular reabsorption returns needed items to the peritubular capillaries. Some of these elements are water, glucose, amino acids, and ions. Step 3, tubular secretion. During this phase, waste is removed from the peritubular blood and moved into the nephron and into the filtrate. This waste consists of hydrogen ions, potassium ions, many drugs, and creatinine. Congratulations! You did it! You've completed all the units. I hope you enjoyed this instruction, and I invite you to return anytime you need to review the material. Again, this is Holly Sanders, and thank you for going on this journey into basic renal anatomy.